All right, well, I've talked about, pardon me, how richly supplied with blood bones are. When somebody is comparing something to a bone, what is the usual saying? Dry as a bone, right? And that couldn't be further from the truth. Bones are deeply invested with a complex circulatory system, and they have a specific, it has a specific name called the Haversian system. Hopefully there will be no aversion to the Haversian system. Yeah, so the way these bones, oh, Jesus. Let's do that. Why it does that. The way the blood first gets into the bone is via what are called nutrient foramen. The word Foramen, Foramen, foramen is the singular word that means a hole, usually in a bone. It's a hole in a bone. Typically, a foramen can be in some other things, but usually it's in a bone. The plural of that is foramina. So nutrient foramina are these holes that perforate bones to bring nutrients into them. Let's see what we have, you guys. So, okay. All right. So there are. Here's one right here, and then there's a few up here on this end. I'll pass this around. You can look at it. This is where having a real bone comes in handy, because you go on this thing, and I'm sure there's no nutrient foramens on the plastic. But you can look here and see the little nutrient foramen. That one. Share the knowledge there. That's how the blood vessels get into the bone. And then once they're in, they pass through these perforating canals. Sometimes you see this eponym called Volkmann's canals. Apparently Volkmann was the person who originally identified them and got his, probably not or her, maybe, name slapped on him. But the name that's used is perforating canals now. And these perforating canals go along to what are called central canals. And central canals in a dense long bone, as Annabelle has here and she's passing around, these central canals run longitudinally along the shaft of a bone. And they run at the center of what is called an osteon. An osteon. Slide projector is doing a poor job, but an osteon it kind of looks like the cross-section of a tree, if you were to cut a tree. In fact, a bone is really a dense collection of these osteons that are sort of bundled together. The center of them has these central canals. And then surrounding that central canal are what are called concentric lamella. Concentric lamella, concentric because they're concentric with the central canal, and lamella meaning layer. So concentric lamella. Now, let's be careful about our terminology, because there's going to be a couple terms that sound very similar but are distinct, have different meanings to them. I don't know why. Oh, the N. Something's wrong with the kerneling here or whatever. That N is supposed to be the end of osteon. Osteo is not. The next thing. So these concentric lamella are bundled together into the shaft of a bone, which is called the diaphysis. Something I kind of skipped in the lecture on bones yesterday, for sake of time. along the shaft of the long bone. It's called the diaphysis. They are bundled in with the circumferential lamella. Circumferential because they run around the circumference of the bone. Just layers around the circumference of a bone. And if you look at this bone model here, this is a wedge, a tiny little wedge that would be taken out of and blown up from the surface of a bone. I'm going to have a slide of this in a moment, but these right here would be the circumferential lamella. These would be the concentric lamella. All right? And then they've sort of pulled out the different layers of an osteon so you can see the different layers that are a part of a single osteon. Now, in the space between the concentric lamella in an osteon are what are called lacunae. Lacunae, plural, lacuna, singular. Lacunae are, in any context, void spaces. They're empty spaces. And in this context, the lacunae are where the osteocytes live. All right, they're inhabited by mature bone cells, osteocytes. An osteocyte itself kind of looks like a star or something. It's sending out tons of little projections, little arms that stick out through what are called canaliculi. Let's say that one together. Come on, we can do it. Canaliculi. Canaliculi. Yeah. Little canals that connect one osteon with another and likewise connect the osteon with the blood supply from the central canal. Now, packing in the void space between the osteon are what are called interstitial lamella. Interstitial lamella, and I don't have, maybe I should go to the next slide. Oh, it is written on here. Interstitial lamella. They're just layers, lamella layers, that fill in the interstices, or the in-between spaces. Okay? Is there anything else on here? Oh, yeah. So this is dense bone. This is the periosteum, the cellular layer that covers the outside of the cell. There's perforating fibers that invade the dense bone of the circumferential lamella and act as the substrate to which tendons are going to attach. So a bone is attached to a muscle via a tendon. Those connective tissue, and what kind of connective tissue? You guys remember from lecture today? What type of connective tissue is it, did I say, that tendons are made of? You guys remember? Very descriptive of what it is. John, yeah. Dense, regular. Densely packed, regular arrayed. Okay, dense, regular connective tissue is going to perforate the bone along with these perforating fibers that penetrate the periosteum. On the inside of the bone is going to be the marrow space, but in that boundary between the marrow void space and the dense bone are these trabeculae. Trabeculae, the word trabeculae is related to the word tribulation. So trials and tribulations. What is a tribulation? Remember? No? That word? Okay, SAT word? High school students. It's like walking a tortuous path, a complicated, interweaving, labyrinthine path. So trabeculae is this labyrinth of bony spicules. The trabeculae is soft bone, these bony spicules that make up the spongy bone. The surface of the trabeculae is covered, and the inside of these canals are all covered with a cellular layer similar to the periosteum, but it's called the endosteum on the inside of the bone. This is the cellular layer where osteoclasts and osteoblasts, osteoprogenitor cells all live. Okay, here's this model. I don't know if Tanner was able to make a digital model of this one or not, but so this is everything that I just described, but identifiable on this model. So we have perforating canals that are coming across this way. Here's a nutrient foramen. Here is the central canal. Each of these round things here is an osteon. These are circumferential lamella with the concentric lamella here. You can see the void space in this portion, which is the lacuna. Here you can see the void space filled with the osteocytes. And here you can see the osteocytes surrounded by the blood supply from the capillaries going through the canaliculi. All right, you see the trabeculae on this end, bony spicules on this end, with a periosteum on the outside here with the perforating fibers that are going into the bone structure. All right, so I just talked about all that. So here there is now, thankfully, my God, that I found all of the histology slides, which were tucked away where they shouldn't have been by somebody last year. There will be some slides. Normally they would be out with the scopes in front of you guys so you can look at them, but we do have now some slides of the dense bone, and this is what it looks like under an actual slide. And you can identify all this stuff here in the slide. This would be an osteon. Here are concentric lamella, central canal. These would be osteocytes. Again, a poor projection, but maybe I can see them you can see them in the PowerPoint when you look at it on the computer. But there are these canaliculi, which are these like hair-like projections that are radiating out from the lacuna where the osteocytes are. All right, so that's all the microscopic anatomy we're going to do. Here are the types of bones. The first type is long bone, humerus, the femur, etc. Most of these long bones reside in the appendicular skeleton, your appendages, your legs, your arms. We have flat bones. The bones of the skull qualify as that. So an example I have up there is the parietal bone. Why do you think the parietal bone named the parietal bone? It's this bone here, the sides of your cranium. I don't know, I guess. I talked about the word parietal in a totally different context yesterday, didn't I? What is that? It was like a parent, but I said in the same way that a parent forms a boundary or a wall. Yeah, so the parietal bones form the walls of your brain case. Sutural bones. Sutural bones. Now, the flat bones of the skull join together via the sutures. And a sutural bone is, there may be people, there's probably many people, most people in fact, may not even have a sutural bone. But a sutural bone is an inconstant bone, meaning not in every person, that is in the suture. It finds itself in the suture. So here this person's got an extra bone that's sitting there. Yesterday I had you guys feel the back of your head for the external occipital protuberance, didn't I? Yeah, the external occipital protuberance, this bone on the back of your skull. This skull here is one that was in the collection when I got here to Colby. And I'm having Livia Stanger, the TA, one of my 2 interns this semester, do some work with this skull. She's going to, hopefully, if we can get all the paperwork done properly, she's going to get a high-resolution CT scan of this so we can have a 3-dimensional model of this and we can look inside of it. Well, I want to see what the sinuses look like to this skull. This skull, I'm going to tell you that the reason I'm talking about this skull now is because it has a sutural bone in it. And it has a very in a specific spot right over the external occipital protuberance. It's external occipital protuberance. This is the occipital bone. And in most of the people in this room, probably all the people in this room, the external occipital protuberance, just a bump, protuberance, that's probably part of the occipital bone. But in this person, it's not. It's separate. That suggests something to me. When I came here 5 years ago, I saw that and my eyes got wide because I've never seen this specific thing before. And the reason it raised my eyebrows is when I was in medical school, I was taught anatomy by a guy, Dr. O'Malley, John O'Malley, at Notre Dame, who he's an old guy and had like decades and decades and decades of history behind him. He was actually a PhD, not an MD, in anatomy, and so he would do a lot of research on different anatomical minutia, esoterica. And he told a story about a sutural bone on the external occipital protuberance, which was kind of interesting to me at the time. After Darwin did his writings in the early and mid 19th century, human anatomy exploded as a course of study on campuses across the United States. And the ability to secure cadavers for anatomy, for cadaver labs, or other anatomical specimens like skeletons is difficult to meet the demand. The supply was difficult. It was hard to meet the demand because there was still a cultural distaste for the notion of taking a person's remains and using them in a classroom setting. So these anatomical distributors would go to places all over, wherever they could, to try to procure anatomical donations. And one of the places that they went was to Peru. And there was a particular population in Peru that were descended from the Incans that by some genetic anomaly in that population had an extremely high incidence of this exact bone, a separate sutural bone over the external occipital protuberance where that should be. And because of that, consequently, a lot of anatomical specimens from the 19th century you can find in medical schools that actually have this bone, whereas it is way overrepresented in those specimens as compared to what you would find in the general population. Yeah?
So are you saying
they can be, yeah. Yeah, within a certain population, there can be a genetic predisposition. Yeah, absolutely. What I am also saying is that the origin of this skull is a little bit in doubt. Here's what I know about this skull. Does anyone want to hold it? Please be very gentle with it if you want. Who wants it? Anyone? Yeah, take a look at it. You can look at it as I described. That skull, tell me, as you're looking at it, tell me what strikes you about that skull when you see it. Yeah, what about the teeth? They're in bad shape. Okay, so now look turn the skull over, look on the bottom, and look in the inside of the mouth, the roof of his mouth or her mouth. What does that look like to you? It's very rough and perforated. What does that suggest to you?
Well, we were talking about the health of
Mm-hmm. Okay. So how many teeth are left in that character's head?
say about
Okay. Yeah, the ones in the front have gotten knocked out by some careless student. But what about the ones in the back?
or
No, in the back of the mouth, the molars.
yeah,
Yeah, or any of the upper teeth. And does it look like they fell out by a student, or have they been gone for a while?
looks like they
Yeah, they've been gone for a while. So that person had probably profoundly bad oral hygiene, right? They probably had really bad oral hygiene. Let's think about why. Can you guess why that person had bad oral hygiene?
well back, oral hygiene.
True, but if that person lived in an indigenous population where they had a diet of unprocessed food with no refined sugars, the actual incidence of tooth decay is kind of low in those populations. And so, while you're right, this may be true, but there could be another explanation. So let me have you do this. Run for a moment your finger along the bridge of your nose, and then run your finger along the bridge of that person's nose. It's short. What else about it? A lot bumpier. A lot bumpier. That person, why would a person's nose be like that? That person probably had their nose broken badly. Probably had their nose broken badly. What happens if you have a really poorly broken nose that doesn't heal properly? Huh? It gets bumpy, but then what else? Say it again. You can't smell properly. What else can't you do properly? Well, taste. Okay, sure. Yes, you're right. Breathe. Who said that? Yeah, you. How? Breathe how? They were mouth breathers. This person was a mouth breather. People who are mouth breathers obligate mouth breathers have extremely bad oral hygiene because of that. People who are mouth breathers have a tendency to have respiratory infection and often die from pneumonia. So I don't know if that's how that person died or not. I don't know what happened to them. But that's what I would guess if I were to guess what happened to that person. The next thing, that skull, the only other thing I know about that skull is it appeared at Colby in 1984 in the men's football locker room. It showed up in the men's football locker room in 1984. Does anybody know anything about the history of Colby College and the year 1984 in particular? That was the year that fraternities were banned on campus. They outlawed campus fraternities in 1984, and that's the year that skull turned up. That skull, does that look like that was a skull that was dug up out of the ground somewhere? Probably not. There's like springs on it. It's got a hole. It was obviously part of a demonstration skull, right? So what would you, super sleuthing it, guess is up with that skull? It's probably stolen from a lab at Colby by someone in a fraternity back in the 19th century and lived in a fraternity house for 100, who knows how many years. And then fraternities were outlawed, and they needed to unload it somehow. So they brought it back here, and it came into the hands of the biology department. I don't know. It's an interesting story in that skull, and I'm not exactly sure what should happen with that skull, what the actual story is, but I know that I want to get more information about it. So I want to get a CT of that and see if we can establish some more information about the origins of that skull. But the point that I guess the larger point, besides telling a kind of weird story about Colby history and that skull that's in our collection, is that bones tell stories. They tell stories if you know what to look at. The features of bones reflect the lives of the people that were investing in those bones. And while I'm not going to require you to look at bones and understand them from that level, for those of you who go on in whatever capacity in the health profession or whatever your relationship with anatomy is, those bones can tell you those stories if you look close enough. Muscles pull on bones, they deform the bones because of that in certain ways. The life that you lead changes the bones, and the record is there in those bones for those who can see them. Was that skull acquired by, did that person donate their body to science, or were they taken by some anatomical distribution company in a nefarious manner? I do not know that. I don't know if it's possible to know that. Probably not possible to know that. But I think we can tell some of the story about how that person probably died. Who, did they come from the Peruvian population? There's a good chance of that based upon the evidence. I don't know, it's interesting story. Opens up an ethical conversation, which I'm going to a little bit of pass on now, unless anybody else wants to offer their thoughts. Okay, so the next bone type, you can just set it down if you want to hand it to somebody else. The next bone type is an irregular bone, and there's a number of different types of irregular bone. Like, for example, the ossicles in the ear are irregular bones. The vertebrae are certainly irregular bones. These are bones that they don't know how to categorize, and so they stick them in this category. There's the short bones, like, for example, the ones in your wrist or in your ankle. Then there are these things called sesamoid bones. Sesamoid bone. Now, the word sesamoid, what does that word remind you of? Seeds. Seeds. Sesame seeds. Yeah, and the irony of me putting up the patella as an example of a sesamoid bone is because the patella is actually quite a large bone, much larger than a sesame seed. Most sesamoid bones, if they occur, are the size of a sesame seed, super tiny. They are bones. The definition of the sesamoid bone is a bone that is entirely surrounded by a tendon. They do not articulate with other bones. They are surrounded by a tendon. So another bone, as an example of a sesamoid bone that we all have, is called the Pisiform Bone. You can feel the Pisiform Bone if you extend your wrist and you go into the pinky side of it and you feel that little bone in the corner. Now, if you kind of grab that bone and then you flex the wrist, you can move that bone around. Actually, the bone should be particularly if you let go. You're not flexing. If you flex, it's not going to move. But if you let go of the flexion and just let the wrist hang, you can move that bone around. The pisiform is another sesamoid bone. So here, this guy, here's his pisiform, right here. His pisiform. And it's contained in the tendon of the flexor carpi ulnaris. Other sesamoid bones are like sutural bones, inconstant. Some people may have them, some people may not. The patella, the pisiform, these are bones that increase the mechanical advantage of a tendon as you're going through the range of motion in a flexion or an extension in the case of the patella. All right, those are the types of bones. Here is the structure of some bones. This is why I didn't talk about it, because I threw the slide in here. The shaft of a bone is called the diaphysis of a long bone. It's called the diaphysis. And the growing ends of a bone are called the epiphysis. So we have the epiphysis and the diaphysis. The separation between the epiphysis and the diaphysis is called the metaphysis. I don't have that word on there. Another name for it is the epiphyseal line. Metaphysis or epiphyseal line. And what's another name for this? Does anyone want to guess? What's the common name for the epiphyseal line? I'll give you a clue. When a bone is growing, they're growing from this point. What do we call that? What's the name? Sometimes if you're like a skater, all my skater pals when I was a teenager, it was like the dreaded injury to that part of the bone. Yeah, it's your growth plate. Yeah, the epiphyseal line is the growth plate. So this is where this is cartilaginous in there in growing people, children and adolescents, and so the bone lengthens like this out that way from the growth plate. Because it's not solid bone, it's prone to breakage there because it's cartilage. And if that happens, you can stunt the growth of that bone. When a person is fully grown, like pretty much all you guys, at this point your growth plates are hardening over and they become dense bone that are visible on x-rays. I think that's it. Okay, so axial skeleton, made of the skull, sternum, ribs, lumbar, vertebrae, sacrum, coccyx. Let's get to the skull. The skull is broken into two groups, the cranial bones and the facial bones. Frontal bone in the front. Parietal bone, yeah, easy name, thank God. At least one of them has got an easy name. Frontal bone in the front. Parietal bone on the two walls on either side. Occipital bone in the back. How are we going to remember the name occipital? Yeah, yeah, absolutely. Yep. Even better. Ocular would be OCU. Occipital, OCC, IPIT. It has the same word origin as unable to be seen. It's occluded. Something that's occluded from your sight is unable to be seen. Ironically, the occipital lobe of the brain, as John points out, is where our visual cortex is. But it's the one bone that is the furthest away from what you can see. It is occluded from your sight. The occipital bone, OCC, occluded. OCC, IPT, AL. All right, the temporal bone. The temporal bone. How are we going to remember that one? What does the word temporal mean? Tempus fugit. Time, yeah. Why do we call the temporal bone time? The time bone. Because it looks like a clock? Complicated mechanism of a clock? No. Where do people who are aging first show the signs of time? For me, it's in my beard. This past year, I got some gray in my beard. Is that? Well, in their hearing, indeed. Perhaps that's it. The way I was told is this is where people go gray first. The gray hair starts here and then creeps up from their beard. I'm a little ways yet from my temporal bone. I got a few here, though. It'll get there eventually. I hope. I want to get there. Sphenoid. let's see if I'll get a better picture of the sphenoid bone. You can see, so I'm going over the cranial bones first. The cranial bones are the bones of the brain case, frontal, parietal, occipital, temporal bone. There's a bunch of interesting portions of the temporal bone that we'll look at in a minute. The sphenoid can be seen from the side, as can the ethmoid. We'll look at a little bit, some better views of that in a moment. And then there's the facial bones. In comparative anatomy, they're called the rostrum. It's like the snout. We have the nasal bones, the zygoma or zygomatic bone. Zygomatic. Dear God. What a name. The zygomatic bone. It's your cheekbones. And then there is the maxilla. The maxilla, which is your upper jaw and kind of the front of your face. And then the mandible, the mandibular bone. That's your lower jaw. There's also the vomer and the lacrimal bone, which can't be seen well from these images. All right, so let's look at the back. Is there anything interesting here? Well, let's name the sutures. I think the sutures. I like cranial anatomy. Cranial anatomy is the one thing that I like here. So the Lambdoid Suture is called the Lambdoid. What does that name suggest? L-A-M-B-D. Lambda. It looks like the lambda, the Greek letter lambda, like the upside down or the triangle. And then the sagittal suture, that should be an obvious one. It lies along the mid-sagittal plane. It connects the parietal bone and on one side and the parietal on the other. Let's look at the top of the skull. We see a little bit of the lambdoid suture. We see the sagittal suture. And then we see the coronal suture. Now, yesterday, I was talking about different planes that slice the body up. We have the frontal plane, we have the transverse plane, and we have the sagittal plane. But there's one other plane that is essentially still a frontal plane. But in the skull, we give it a special name. We call it the coronal. A coronal section is a frontal section taken specifically in the head. All right? And we call this suture the coronal suture. Why? Is that because that's the part of your brain hurts if you drink too much Corona? Maybe.
Crown.
The crown. It's the crown of your head. Right? Corona means crown. Yeah, sir, Chris.
So is it's where two bones connect, or is it a separate?
No, it's a connection point, a junction. And we talk about sutures. Sutures are important because in utero and in newborn infants, the suture is not actually formed. It's mostly cartilage or nothing, and that allows the head to swoosh as the baby comes out the birth canal. Man, I want to teach a class about embryology, development, birth, and childhood. It's kind of the most fascinating part of the human experience. Anyways, this is why babies that have been C-section, cesarean section, their heads, you can often tell because their heads are so perfectly shaped. They have ideally shaped heads, whereas natural childbirth heads often have these like kind of weird egg heads because they had to fit through the birth canal. It goes away. Soft spots eventually fuse. All right, so the one suture in the skull that we didn't mention is called the squamous suture. All right, we've come across that word already. What did I say? Squamous, S-Q-U, squished. That suture doesn't look especially squished to me. Can anybody guess? Take up the skulls that are near you. Tell me, why do you think the suture along there might be named the squamous suture? I'll tell you this. It will help you if you take off the calvarian is the top of the head, the top of the skull. So they call that the calvarian because I went to a Jesuit high school. This isn't to say that I'm particularly Catholic or anything, but they forced me to go to all these religion classes, and Jesus was crucified on a hill called Calvary, right? And the Calvarian is that hill, the mountain upon which Jesus was crucified. I don't know. I didn't name it. That's the word origin. The Calvarian is the top of the skull. You take that off. Now hold up your skull. Hold up that skull to the window, to a light source, to a light, and look at the part of the skull right around the squamous suture. What do you see? You can see through it. Light comes right through it. The bone, the temporal bone, this part of the temporal bone is called the squamous part of the temporal bone. It's the squished part of the temporal bone. It's thin. So we call that suture the squamous suture. All right? Is this helping you remember these terms? Tell you the stories? What else? Well, this is an interesting story. This thing here is called the styloid process. There's a couple plastic skulls out there. Pick up a plastic skull and find the, here's one. Here you go. See if you can find the squamous, the styloid process on that. Can you find it? This thing, this little spike. Easy, right? No problem. Now find it on Maria, right? Yeah, please find it on that not living or breathing actual skull there. Is it there? Can you find it? Is there one on there? No way. Oh, it is. Yeah, sort of. Let's see. Most of them don't have it. And yeah, there's one on this side. This one snapped off of it. If you take a skull and you disarticulate the lower jaw and you set it on a counter, you will snap off the styloid process. So a lot of actual human specimens have the styloid process snapped off. It makes a skull considerably less valuable, I guess. I don't know. You're not even allowed to sell these things any longer, so that's a moot point. I don't think. I believe these kinds of, the market for these anatomical specimens is, I don't think you can buy them anymore. I don't know. Maybe wrong about that. Anyways, the styloid process attaches to a muscle called the digastric muscle. If you take your hand and you go into your jaw line right here, that you're going to find a bone, not the thyroid cartilage, but a bone right in the angle of your throat. You can grab it, you can move it side to side, you're going to feel it. It's called the hyoid bone. It's this bone right here. See that? That bone. A muscle that originates on the styloid process attaches to the hyoid, and then it comes down and attaches on your collarbone down here. And it keeps that hyoid tucked up in here. If you didn't have a hyoid bone, we'd all look like Mitch McConnell, and our throats would, that was an unfair jab at Mr. Sorry. All right. It would take more than that to look like it. What else do I want to see? Oh, yeah, here in the orbit. You can see the ethmoid a little bit. You can see in this view the lacrimal bone. The lacrimal bone is kind of a diminutive bone, and because of that, it is lacrimose. What is the word lacrimose or lacrimal refer to? Tears. Someone who's lacrimose is tearful. The lacrimal bone contains the tear duct that transmits tears into the nasal cavity from the eye. Is there anything else? We'll get back to the temporal bone. I'm going to tell you one more story about the temporal bone. All right, so here's the front of the skull. You can see part of the ethmoid here as well. So here's some ethmoid, here's some ethmoid. No, this is part of the ethmoid. These are the nasal concha. So, the reason that mouth breathers have a hard time is because they're getting unfiltered air. If you breathe through your nose, we're filtering the air. And so these nasal concha, otherwise known as turbinates, are some more bones in the skull. I'll just tell you this. There is as much or more anatomy from your neck up as there is in the rest of your body. The skull has so many detailed features to it that it's kind of confounding. But we're just going to lightly scratch the surface here, help you identify the bones. They're also called the turbinates. So a concha, a conch is this spiral thing. They look like that. They kind of, I will show you a picture eventually of a cross-section of the head where you can see the concha as these curled bones, also called turbinates because they cause turbulence in the air as you breathe in, which causes any kind of particulates or junk, pathogens that you may breathe in to stick to the walls of the mucus in your nasal cavity so that you can blow it out as a booger rather than inhale it and get pneumonia and come to an untimely demise like people who have bad breaks in their nose. There's another bone called the vomer. Can't see it very well here, but it's basically part of the nasal septum. So half of the nasal septum is what's called the perpendicular plate by the ethmoid. Ethmoid's a hard bone to visualize. There is a box next to Grace here. You see in the wooden box, there's like a cardboard box in that box there. A box in a box. Right by it. No, yeah, one of those. I think it's that one. Maybe it's one of those two. Oh yeah, not the ribs. The disarticulated skull. Yeah, the disarticulated skull. There's an ethmoid bone in there that you can take out and look in isolation. They're pretty far out looking bones. The only reason I'm going to spend much time at all on any of these skull bones is that when I talk about the brain, it kind of helps to know a little bit because I'm going to talk a little bit about some of the features. Vomer is just kind of a triangular shaped bone that runs down the midline of the nose. Here's the underside of the skull. This is really where I talked about how anatomy is all about anatomical relationships. And this is where finding an anchor, an anatomical anchor, is good. Like identifying something, knowing something that you can always identify, and then building anatomy off of that. So, for example, here is the Foramen Magnum. What does Foramen Magnum mean? The big hole, the biggest hole in your head. The biggest hole in your head. What do you think the Foramen Magnum is? Smile. Okay. You guys are sure. On either side of the Foramen Magnum, if you look at the bottom of your skull there, are the Occipital Condyles. Now, condyle is just a word. There's a lot of words here. I'm not going to give you all the terminology that is used to discuss anatomy completely because I'm not. But condyle is a word for an articular surface. It's one word that is sometimes used for an articular surface. So a condyle is a surface of a bone that is often covered with cartilage and is used for the articulation. So articular condyles, all you sharp cookies. What do you think the occipital condyle is? What does that do? Actually, the cervical vertebrae, but yes, you're correct. The cervical vertebrae connect right there at the occipital condyle, called occipital because they're part of the occipital bone. There's two relationships. Foramen Magnum, super easy to identify, the biggest hole. Next to it is the occipital condyle. All right? Moving medially, we have the jugular foramen. The jugular foramen, what would you guess the jugular foramen does? Liam, you're smart. Get it. What do you think the jugular foramen does? Yeah, the jugular vein goes through it. Real obvious one. Real obvious. And then anterior and a little bit medial to that is the carotid canal. All right? So notice, I'm not just saying, here's the carotid canal, here is the foraminal volley, there is the other thing. I'm building relationships for you. Okay? I'm building relationships for you. That's how you study anatomy. You build relationships. Okay? For those of you who go to medical school or nursing school or dental school and have to take a higher level anatomy class, if the instructor doesn't tell you that, then they are remiss. I have told you that. That's how you learn it. You build relationships. All right. What else do I want to talk about there? I'm not going to go through all the holes in your head. There's a lot of them. So there's a pretty decent picture of the sphenoid bone. The sphenoid bone this is the underside. It looks a little bit like a butterfly. It looks like a bat or a butterfly. I don't know what it is. It's this incredibly complicated bone that is in the middle of your head. We're going to look at it a little bit more on the other side. What else do I want to point out here? Mastoid process. So mastoid process is a feature of the temporal bone, and you can feel it right here if you put your hands behind and underneath your ears, not the angle of your jaw, but it's this big bony lump that's behind your ears here. That's the mastoid process. And if you go from that and you travel down towards your collarbone, that muscle you're tracing is the sterno meaning sternum, cleido meaning clavicle, sternocleidomastoid. It attaches the sternum, the clavicle, and the mastoid process, the sternocleidomastoid bone, mastoid bone. Anything else? The palatine bones. Palatine bones are the bones of the hard palate. 2/3 of the anterior portion of the palate is from that. No, I'm sorry. 2/3 is from the maxilla. Scratch everything I just said. Anterior 2/3 is the maxilla. The posterior 1/3 is the palatine bones. There's 2 of them. I don't know. Maybe there's only one. Man, I am soft in the brain today. Pardon me. Maybe I should get off of this slide before I stick my foot in my mouth anymore. I think I'm done. Okay, so let's look inside a bit. This view gives us a better view of the vomer. Here's that plate of the ethmoid. You'll notice in the ethmoid, if you look in the inside of your skull that you have near you, towards the anterior portion of the brain case where the ethmoid sits, there's these holes that perforate the brain case there. Those foramina are for the olfactory bulbs for smelling. All right, here is the inside of the brain case. I love it. Okay, so now we see the sphenoid again. Here's a little bit more of the ethmoid. And these holes that you see are called the cribiform plate. Cribiform just means perforated plate. This is where the olfactory bulbs sit, like this and like this. Your smelling bulbs, the nerve of smelling. And they send nerve rootlets down into your nose, into the nasal cavity. In between the 2 cribiform plates is the crista galli. Who here speaks, I've already asked if any of you speaks Latin. What about Spanish? Okay, what does crista galli suggest to you? Oh. Crista galli. Galli. It's not actually Spanish, so I'm putting you on the spot. Gallo is the Spanish word.
Oh, I thought that was like a far cry from that, and I was just like, I'm just not going to say that.
No, it's it. It's
like the rooster's
It's
head.
the rooster's comb, the crest of the rooster. coxcomb. Yeah, it's the crista galli is a little ridge, and you can feel it in there, and it separates the olfactory bulbs, which we'll talk about when we talk about senses. This spot right here is going to be significant when we talk about the hypophysis or pituitary gland. We call it the Sella Turcica. Sella Turcica. The Turk's saddle. The Turk's saddle. They imagine it looked like a Turkish saddle. So you can imagine a little Turkish rider sitting there in the Sella Turcica. In fact, it's not a little Turkish person, but it's going to be the pituitary gland. We'll talk about that in the endocrine. We'll talk about endocrine in the brain. Last thing in the brain I want to talk about is this part here. This is called the petrous temporal bone. So if you look in the in your brain that you have there, you'll see these ridges of bone, and it's part of the temporal bone. Yep. So right here and here, it's kind of like almond-shaped ridges of bone. They're called the petrous temporal bone. What does the word petrous mean? What does petrous mean? So, what's saltpeter? Another name for saltpeter. Okay, this is the Jesuits coming out of me again. Simon was on the road to Damascus when he was. You will be my rock upon which I will build the church. Petrous means rock. The petrous temporal bone is the densest bone in the body. It's actually the hardest bone in the body. Does anyone want to take a wild stab at why the petrous temporal bone is what it is? Huh? The way the who? The brain certainly sits on top of all of this, but there's a lot of part of the brain that's not anywhere near the petrous temporal bone. So that's a good guess. You're thinking about the right thing. You're like protecting. You're trying to protect the brain, right? We're trying to protect something here, but it's not actually the brain. Come on, I'm listening. Give it to me. It does. The three tiniest bones in the body, the most delicate possible structure in the human, the middle and inner ear, is perfectly residing within the petrous temporal bone. So here's a little fun thing. Maybe it probably only applies to a few of you, but when a few of you who do get to go to a cadaver lab at some point in your careers, the instructor may or may not have you dissect the middle and inner ear. They usually don't, because a lot of instructors don't even know how to do it properly themselves, and students often myth it up. But the way to do it is to dissect through the petrous temporal bone, and I'm going to tell you how to do it. You take a little bone saw and you score along here and here, along those almond-shaped margins. Take some rongeurs, which basically look like big wire cutters. They're just like a bone cruncher. And you stick the blades in either side that you scored. You kind of like just give it enough to snap it off. And the top of this will pop off of there and reveal, hopefully, a beautifully dissected middle and inner ear. It is worth doing. It is worth going off the syllabus when you find yourself in that circumstance in medical school or nursing school or someplace. All right, I'm getting towards the end. Oh yeah, here's the petrous part of the temporal bone. So you score along here and here, and then you'll have three teeny tiny little ear bones, which is a pretty cool thing to look at in your hand. You'll get to see the labyrinth, the whole thing. It's really cool. I'm not going to go through any of this. I'm done with all that. Done. Oh, here's the ethmoid in isolation. Weird looking bone. Look at that bone. That is just a weird looking bone. So, yeah, I don't want to go through all this with you. So here's the hyoid that I was speaking about earlier. I pointed out all those bones, which was, oops, man, I'll give you guys motion sickness. The sinuses, why don't we talk about that for a moment? Sinuses are void spaces in the bone that give our voice various sonority and help with the filtration of the air that we breathe in. There's a frontal sinus that lives up in the frontal bone, of course. Maxillary sinus, named for the maxilla. Ethmoidal air cells are the teeny tiny little holes that are in the various sinuses. I have a sinus model someplace. It hasn't. TA must not write it out. I do have a model. Oh, here it is. And then the sphenoidal sinuses behind the ethmoids round out the bulk of the sinuses. So yeah, some of them are broken in there. It may have gotten dislodged. Okay, I'm going to stop talking because the rest of it, I'm not going to tell any more fun stories about any of the bones because I don't really. Actually, I'm going to give you one last thing here. This is the one last thing about bones. The first two vertebrae, the first C1 and C2, the cervical vertebra, have special names. And I'm going to give you those because that's important as well. The first one is called the atlas. Why do you think? It holds up the world, just like the Greek god Atlas, one of the Titans. Yeah, it's holding up the world. And then the one below it is called the axis. The axis. Now, the atlas does not rotate with respect to the skull. The axis does, which is why we call it the axis. The axis has a special feature on it called the dens. Does anyone want to guess what dens means? The tooth. The tooth. Exactly. Thank you, Meryl. The tooth of the axis. This is the pivot point for being able to turn your head. So, two special names of the first two vertebrae. I'll give you a couple tips on identifying vertebra, maybe as well. So, in all of the cervical vertebra, which there are 8, there are these, in the transverse process of the vertebra, there are these transverse foramen. None of the other vertebrae have that. None of the other vertebrae have that. That transverse foramen is where your vertebral artery goes up into the brain. 1/3 of your blood supply to the brain comes through the vertebral artery. 1/3 of your blood supply goes there. The other 2/3 come through the carotids, but 1/3 of them go here. And in fact, there is, I think it's in Lachman's, you can read about it. I think there's a story in here about death by hanging. Yeah, the anatomy of a hanging. If you want some like fun bedtime reading, page 68. It'll talk about the vertebral artery and the transverse foramen. All right. And then the thoracic vertebra are special in that the transverse process does not have the foramen because there's no vertebral artery, but there is this costal facet, a costal facet for the articulation of a rib. That's how you can identify a thoracic vertebra. The ribs have this, there's on the transverse foramen, on the transverse process, there's this a special facet where the ribs insert. And then in the lumbar vertebra, there's neither of any of those things. They're pretty easy to identify because they're huge. They're much larger. The body of the lumbar vertebrae are huge. Okay, that's it. I'm not telling you that I don't want you to know the names of these other bones, but I'm not going to go over any of the specific pieces. You guys can identify the remaining bones on the body. I don't want to talk the whole remainder of the time. There's a little bit of time left for you. Any questions? There's the acetabulum. There's so many good stories to tell. Okay, I'll leave it with that. Okay. Any questions? No. So what I suggest you do is take the lab outline. Where is the lab outline on my computer here? Do I have it? Up. No, let me find it. No. It's going to take me a minute to find it, but you can go and find the lab outline. Actually, it's probably in the Moodle. I'll just go to the Moodle, just like you would have to. Let's go to the Moodle. All right. Oh, here it is. Look at that. Lab outline. I downloaded it. So what you can do here in the lab outline is just go down to Lab 2. These are the features on this model that you want to be able to identify. Just go down the list. Can you identify it? Did I say something about it? Write down what I said about it if you want to remember it. But can you identify all those things? Axial skeleton. I talked about all of these things in this list. Be able to identify them. In all of these facial bones, I didn't do any. I'm sorry, that is such a poor projection. Let's see if I can make it bigger. Yeah, I guess so, right there. I didn't ask you to know where the infraorbital foramen or any of this stuff is. Just being able to say that's the maxillary bone, that's the zygomatic bone, that's the lacrimal bone, mandible, that kind of thing. Humerus, femur should be possible. Should be possible. None of the osseous features. Just go down that list. This is your Bible. In the bone section, at least, only use the left to justify none of this other stuff for any of the things that I haven't. Okay.